Welcome back. My name is Engr Shamsher. Today the topic which I'm gonna be present is Hooke's law. So before going to explanation, we should know about what is meant by Hooke's law. Hooke's law is firstly a sentence which is told us about the concept of matter, fluid. Fluid is including gas or liquid, but we are talking about here fluid or gases. So what is meant by Hooke's law? Hooke's law, this law states that when a force is applied by a string, compressed or expanded, it is directly proportional to the restoring force. For example, when we apply some force on a spring, so due to applied force, it will expand. As you can see in video, this is the original shape of the spring, right? And after elastic force, then you can see the spring is to be enlarged, right? Because the restoring force is directly proportional to the applied of this elastic limit. So as you see the example in front of you, when a wire is to be extended, okay, so there is so many parameters to be infused in here. I will gonna be explain one by one. So what is mean by stress? As you can see, when we applied some force, so in this body some stress is to be produced. So gentlemen, what is meant by stress? Stress is defined as force applied on a cross-sectional area to produce deformation. There is a huge difference between pressure and stress. Stress is being deform a body. They will change the body shape, while in pressure there is do not be occur any type of change, right? So basically when we applied some force, due to restoring force, the body will be deformed. So the stress is generated. As you can see in a video, stress is stress force divided by area, where force is telling is about 4 Newton. Unit of force in Newton into meter square. Gentlemen, basically this stress is telling is about the elasticity of the any product. Okay? I'm coming toward the strain. What is mean by strain? Strain is defined as the extension of length or change in length divided by original length. This is you can see. This is, for example, the spring is 2 meters, and after you can see it will goes up to 3 meters. So the strain is change in length divided by original length. You will check the elasticity of this spring. Gentlemen, now we are coming to the Young modulus. So what is mean by Young modulus? You can see Young modulus is basically defined as strain is directly proportional to strain. Basically, as you can see, by apply of stress, the strain is to be occur. Before the original shape of the spring and after the shape, after the elastic force of the spring, you can see a huge difference. So Young modulus of elasticity. When you further enlarge so the spring is to be break out. But how? By express stress is directly proportional to strain. Y is equal to Fl by X. As you can see in a stress strain diagram, you can see what does it mean stress strain diagram? Stress strain diagram is basically tell us about the behavior of elastic force, right? As you can see, when a body is going to be in elastic limit, so the restoring force is being applied, right? Because this is the elastic region and this is the plastic region. When a body until to the elastic region, the body, the spring is do not be break. When it will increase by applied force and the force is being increased, so it will go to the plasticity and the body is being to be break out, right? So basically the Hooke's law is just applicable for elastic limit. You can see is here, it is just applied for elastic limit. For plastic, you can see when an object is break out, so there is no Hooke's law is being applied. Gentlemen, there is the best elements product for elasticity is nickel and iron. Nickel and iron is the best elastic product. We can see nickel and iron is the best conductor for this elasticity, right? So basically, generally we are telling about the stress strain diagram. Hooke's law just tell us about the elastic limit, not to the plastic limit. Plastic limit is just goes to be breakout, and elastic limit is just wind up for the strength of the wire or spring. Okay, I think that's enough for today. Thank you. Thanks a lot.